Hi, I'm Les Bowling. I'm the EE designer and one of the partners for TrueStep. Today in this short video, I'm going to explain the basic operation of the Bluetooth interface and how the sensor module is structured and architected. The sensor module that's in front of me here, it contains a lithium polymer battery, a rechargeable lithium polymer battery, a battery charging circuit in combination with the battery safety circuit, a three-channel sensor input module with the surrounding amplifiers and electronics to support that, and then a Bluetooth interface system on a chip, SoC, to host the Bluetooth interface and also provide all of the algorithms and the operation of TrueStep. So with that, we have a little, for the prototype stages and the initial release, we have a flex PC or flex cable coming out to a I/O board that is a three-channel I/O board that would connect the heel, lateral, and medial sensors. And what will be laid out in the actual foot or the insole is the heel. This is a TechScan A401 pressure sensor, and it would be in the heel, the medial, and the lateral, and they'll be positioned accordingly. So the basic operation of this is I'm going to use an application that it's a prototype development and debug application that is free to download. It's light blue. So we can use this to scan and to develop Bluetooth interfaces and to be able to test and link to the system. So as right now, when I started light blue, it's actually scanning for any kind of nearby devices that is Bluetooth low energy. So Bluetooth low energy, Bluetooth smart, and Bluetooth 4.0 are all comprised in the same terminology. And today we'll refer it in this video as Bluetooth low energy. So whenever we start TrueStep, we just push the button, and as soon as we push the button, you'll notice that it found TrueStep, and it has two services associated with it. It has a device information service, and then the command and control and data interface service. Along with the advertising, currently what's advertising is the serial number. This app doesn't show that, but when you're developing an application, an iDevice or an Android application, you can scan the serial number associated with this. So this will allow you to connect. You could have multiple modules transmitting all at the same time. That'll say TrueStep, but in the background, it's transmitting the serial number. So I'll connect to TrueStep, and so it connected wirelessly to Bluetooth. And one of the things that's in here is the device information, as described earlier. It has manufacturing name string, which is TrueStep LLC currently. The model number of this device we called a BARDA, and the serial number that's currently programmed into this device is serial number 3. We could change that with the wireless background command set. So Bluetooth low energy differs significantly from Bluetooth Classic in that it uses a special protocol that allows you to have characteristics broadcasted out under an associated UUID and a special characteristic number. With that, you can you can link, and you can talk to each one of these characteristics. Each one of these characteristics are tied within the code to various variables, various operation points. So it's broadcasting the heel sensor percent output, which is you'll end up having three individual outputs: percentage of weight bearing load, which would be the heel sensor, the lateral, and the medial percentage output. The total sensor output represents the combination of sensors that you've selected. So upon startup on the GUI, if once you've reviewed the user interface, one of the startup phases is to be able to select which sensor you want, or a combination, or any combination. So you could just use the heel, lateral, or medial. You could use any two or any three, the way it's set up currently. So, so then there's a sensor state that depicts the current state of the sensor. So right now it's reading 7. Now, this represents a number table that is defined in this command and control interface and data table. 7 represents no sensors configured. So currently there's no sensors that has been programmed. So we switch back to the characteristics and broadcast of, that's the current state. The sensor battery low give you an indication of whether the battery is low or not. Currently it's not. This would be a 0 1 flag. Now what this all represents is all of these variables are being broadcasted concurrently, and they're auto notification properties, which means that when you build an app, when you build an iPhone or an Android app, you can listen for characteristics for notifications. You can listen for various changes within all of these characteristics concurrently, which will allow you to monitor and live real-time monitoring, which makes this application really cool in the sense that whenever after you go through the sensor setup, the calibration stages, and in a runtime mode, these are live updates. So whenever you're pressing on the sensors, weight bearing load on the actual heel, lateral, or medial sensors, you'll have a percentage output which equates to the percentage of the current weight bearing output that you've set up. So the device actually captures a weight based on your weight on a good foot. So during the calibration process, it captures a value. It's not interpreted as a weight. It's not presented out in the real world as a weight. It's actually a static value that's obtained to be as a reference for comparison with the actual runtime weight. So then whenever you choose a percentage, whenever you select the weight bearing percentage, if you selected 25%, then it would use 25% of the captured weight bearing percentage to output on the sensor output here.